Good afternoon. My name is Bill Booth, and I'm a Senior Electricity Advisor at the U.S. Energy Information Administration. I will be presenting today. This webinar covers EIA's U.S. Electric System Operating Data Tool. The webinar gives an overview of the features of EIA's web tool and answers questions about the way the data is collected and displayed through the online tool. Let's start with a few key takeaways. Since mid-2015, EIA has been collecting near real-time hourly system demand data from each of the U.S. electric systems in the lower 48 states.
This data is being processed and posted within an hour and 20 minutes of the end of the operating hour. And the web page and the data collection serve several objectives that we'll talk about in a second. And we have a number of ways that analysts can get access to the historical data for doing their analyses. We're calling this version of what you see on the website a public beta, and the primary reason for that is that there are some significant data issues that we're still working through. But, you know, the website is up there for people to look at and use, and the URL is down at the bottom of the page. All right, so just to give you a quick idea of what we're going to do, I'm going to talk a little about the data itself, what is it that we're collecting, and then talk a little about the project objectives that I mentioned earlier. But we're going to spend most of the time looking at the web page and talking about data access. How can you get the data? And after that, as John said, we're going to be open to answering questions. All right, so what are we collecting? So we are, as I said, every 60 minutes, we are collecting an actual hourly demand, system demand value from each of the 66 electric systems, which are called balancing authorities. I'll explain that in a second, that operates the U.S. electric grid. We take that data and turn it around, as I said, in an hour and 20 minutes after the operating hour. So, for example, so we're past 3:20, we should be able to see data for 2 p.m. Eastern time on the tool. So we'll see, cross our fingers, we'll see if I'm correct on that. That doesn't always happen. In addition to the actual system operating demand data, we collect some other information, not on an hourly basis, so it's not as near real time as the demand data. And this includes, well, so this collection comes in the morning and typically posts this by 8:20 in the morning Eastern time. And included in this data is an hourly load forecast for the current day. What this allows you to do is, with that load forecast, you can then compare as each hour comes and we receive the actual demand value, you can compare that to what the forecasted demand value is. And then for the prior day, we get 3 values. We get net generation, we get net actual interchange, which is the flow of electricity either in or out of the electric system. And then we get an updated set of values for actual demand for the prior day. So you might wonder, so why are we collecting this information? So I think hopefully it's evident why collecting hourly system demand is of value. That is basically what's driving the electric system. Of course, the electric system, one thing that's unusual about the electric power industry is there's essentially no storage. So the supply into the system is driven by demand. That the system is designed to maintain a balance between supply and demand in real time. And so the 3 elements that we're collecting here, the net generation or supply, the actual interchange, which is the flow in and out, and the demand are the 3 elements that make up that balance. And that's why these entities that are reporting here are called balancing authorities, because their primary function is to maintain that balance between supply and demand. And so that's the focus of this collection, is essentially demand, but in addition to demand, system demand, but in addition to that, also collecting the other element of that balance that is a essential feature or function in the electric power industry. All right, so let's move on to some of the objectives of this project. What can this collection do for people? So a primary thing is the near real-time collection of demand data provides some situational awareness. What's the status on the electric system? How quickly is demand growing, on a hot day, those types of things. In addition to that, we're expecting this to be of use in providing some ability to track recovery of electric systems that have experienced a disruption. So that may be of particular value. For me personally, a major objective of this is education. What this tool can provide is a better understanding of the structure of the electric power industry and some understanding of the dynamic nature of how the industry works. And then a third objective is particularly the system demand information, and the dynamic nature of it, as I mentioned before, is a essential piece of information if you want to try to evaluate essentially almost anything that you want to do in the electric power industry, but particularly some technology development, say renewables, wind and solar. Those are particular technologies where the time of day is very important in terms of what you can expect to get out of those technologies. And to understand their value, you need to match that up with what the shape of the demand is, changing nature of demand. And also a number of programs or policies in the industry, smart grid, energy efficiency, demand response. The value of those depend on when they're implemented, during the day or during the week, those types of things. And then another way of saying basically the same thing is that developing and implementing a number of technologies and programs can be helped by understanding how to take advantage of the varying nature of electric system operations. So those are just three of the uses that we foresee for this information. There's others out there. All right, so let's move to the next page. So we're almost to the point of moving into the demonstration. The approach I want to take on the demonstration is, instead of just sort of clicking through various pages, I want to use the tool to answer a simple question somebody might have about what's going on in the electric industry. The question I picked out here is to ask is, to what extent does the New England system rely on electricity from outside their system? And then in addition to that, answering that question, we're also going to be talking about ways in which analysts can get access to the historical data. All right, so let me move on to the tool. Are there any questions, John, that have come in that we should address at this point?
Well, we could address a question that's come in.
Okay.
One question is, what weather model do you use for your demand forecast?
Oh, that's an excellent excellent question. So we do not forecast demand. So the basis of this tool, if I didn't make that clear, is an information collection to the 66 entities who have the responsibility for maintaining the supply-demand balance in the industry. And one of the ways that they maintain that is that their job is to schedule generation facilities to be available to meet demand. And so a major way that they do that is they do demand forecasts, and of course weather forecasts are an essential part of that. So EIA, the data related to demand forecasts from these balancing authorities is not something that's coming from EIA. These are demand forecasts that are being reported by the balancing authorities themselves, and they actually produce quite a few demand forecasts to do their job what we've asked of them is for them to provide us their day-ahead demand forecast. And that one of the two of the reasons for asking for the day-ahead demand forecast is that's typically the demand forecast that they use for unit commitment. That is the decisions to which units they're going to have available the next day. And then another reason that we wouldn't have, demand forecasts that these systems will do demand forecasts throughout the operating day. But if we were to do that, we wouldn't get it in time for us to be able to put it into our tool. So by asking them to use basically we're asking them to report demand forecasts that they have available when they're reporting their information in the morning of the operating day. All right, so let's move to the tool. All right, so here is the tool. So when you load up the tool for the first time, this will be the default page that you'll come to. There are actually several primary pages associated with the tool. There's 3 of them up here, up in the upper left-hand corner. And there are 3 tabs to get to them. So this is the overview page, and there is a map page, and then there's a detailed data page. So this overview page is intended to provide sort of a high-level view to use some aggregate data, and we aggregate the data. So the basic data that we receive from the balancing authorities is hourly data. Everything's hourly. So what we're doing here is looking at daily. We can look at daily and we can look at weekly. We get a full calendar year of data. We'll probably add a yearly tab to this to provide some look in from that perspective. But so we're aggregating this by time, and we're also aggregating it by geography. So when we're looking at U.S. level data. So this is data for the whole United States or the 48 lower states. And then we also can look at this data on a regional basis. So, and by default, we come in at the U.S. level, at the daily aggregate level, and it shows us the current day. So over on the right-hand side, we have the dates here, which you can change, and we'll do some of that in a second. All right, so we're looking daily data here, and the chart over on the left-hand side of the screen here is showing demand, hourly demand for today, and you'll see a whole bunch of lines here, and I apologize, it's a little difficult to see, so you'll have to take my word for it. We'll see it a little better in a second, but in amongst there's a blue line, which is, we call it the chosen day. Well, the chosen day is the default day at this point, which is today, sort of hiding in between the other lines there. And what we're doing is showing the information we have for today, trying to show it in context. So the context is we want to compare it to what happened yesterday, what happened the same day of the week last week, so Wednesday last week, and a year ago, the same day of the week a year ago. And so as I said, the blue is sort of hidden in here, current day. If you can see it, you'll notice that there's a dotted line up toward the top. That's because that represents some hours that we have not gotten to yet. And so what we've done is that we will show a solid line for the hours that we have the data for, and we have a dotted line for forecast data. So we're mixing actual and forecast for today. And you can just see here, last week, the green is a little bit higher than today, and that's just indicative of the fact that last week was a little hotter. In toto, we're seeing it's a little hotter sort of all across the country. But yesterday and a year ago is just a little bit below what today looks like. So I want to talk a little about the regions. So this is the map over here is a selector for the regions, and you can mouse over and see what the various regions available are. And what I wanted to do is select New England, since the question we want to answer has to do with New England, so we can just take a quick look at New England here. So this is a little more disaggregated, and so we have a little more separation between the lines. The thing I find interesting about this one is that the relationship between the lines seems to be different in the morning than it is later in the day. So that's kind of an interesting result there. Not quite sure what that's all about, but it's an interesting question. All right, just wanted to mention on this particular overview page, I've been talking about this demand tab here. If you look in the upper left here, under the ticker on the top, there's actually sort of 3 sub-pages for the overview page. We've been looking at demand. There's a trade page. This page shows you information about imports and exports of electricity to Canada and Mexico. And then there's a write-up about the grid, which gives some basic descriptive information about, you know, what U.S. grid is and how it operates. So this is hopefully some useful background information for you to look at to understand better the information that we're presenting here. All right, so what I'm going to do is reload the page just to make sure that we're looking at the right particular time, and then move to the second page of the 3 that make up the tool. And so this is the map. All right, so the first thing to know about this map is that this map shows information about one particular hour. And there's some controls up in the upper right-hand corner, and you can use those to pick the particular hour that you want. By default, it goes to the most recent hour for which we have data. And what I'm noticing here is that down here is a message to say when it was last updated. And looks like we have a little bit of a network problem in terms of getting our real-time data. So we're only showing noon at the moment. Let me just see if we can move up to 1 o'clock. So this is 1 o'clock. It looks like we've gotten some of the data, but not all of the data. And if I try to go to 2 o'clock, which is what we should be able to see right now, it's not going to even let me do it. So we don't have data for that. So I apologize that we're not able to show you the most recent data, but this is the nature of the beast at the moment. So let's move back to 12 o'clock, talk about this. All right, so one of the things that by default I wanted to mention was by default you come in at Eastern time, but you can use these controls here. Just click on these little pies or the name there, and you can see the information from a different time zone. Also point out this value at the upper left, this is the total demand in the lower 48 states for electricity for the hour ending noon today. All right, so what are we looking at here with this map? So this map is a schematic diagram of the structure of the electric system, how it operates. Underlying the map, you'll see three colors. There's sort of I'm not sure what that is, but purplish, light purple color in the west. We've got green in the east and tan or gray in most of Texas. So those different colors are indicating what are called interconnections. That's interconnections with a capital I. They reflect the fact that the U.S. grid actually has three parts to it. It's not a single grid. What happens within interconnections is electricity is free flowing. There are no barriers there, or few barriers there, but there is an ability to, but the movement of power between interconnections, the three areas I talked about, is limited, and they're indicated by these little ties, bow ties, that indicate facilities that allow power to move back and forth, but they're not. That's not being done freely. You actually have to set that transfer to a specific level. All right, the circles. What are the circles? The circles are the 66 balancing authorities in the U.S. And the size of the circles are sort of roughly reflect the peak load for those systems. So you can see PJM and MISO and ERCOT and SPP are some of the largest systems in the country. Some of the smaller circles on the map, if we were to actually do it based on their peak demand, you wouldn't probably see them, or they'd be at dots. So it's, as I said, just roughly. The lines between the circles reflect one or more physical transmission connections between the systems. So if two circles don't have a line between them, that means they're not directly connected with each other. All right. So what else do I want to say? All right. So one thing you can see here is we've got some colors in the circles. One is black. So black is not good. Black indicates that we're missing one or more of the data elements. Here's BPA has not been sending their hourly data in today. And I think that's the case for most of the other black circles. And this happens periodically, and we follow up with them quickly. We've had communications with Bonneville today about this issue, and they usually get back online pretty quickly. The other colors, the main colors you see here are the blues and the oranges. There are various shades of those, and those indicate a relationship between the actual and forecast demand. I said that relationship might be something that people are interested in seeing. And so a blue circle means that actual demand is below what the forecast demand is. The oranges indicate the actual demand is above forecast. And the intensity indicates, the percentage above forecast or below forecast. And so that, can indicate, particularly if it's, dark orange, a mismatch between what the operators expected through their forecast and what they're actually seeing. That may mean that their system is under stress.
And Bill, just to clarify, the over demand or under demand, that's not, is that the running total for the day or just for that particular hour?
This thing is just for one particular hour. Yes, good question. All right, so why don't we move to talking about the answering the question that I raised at the beginning of the demonstration. So if I want to look at New England's reliance on outside sources, I want to look at New England, of course. Now, questions like this are ones which people typically want to know for a particular hour of the year, which is the hour of the maximum demand. And so we'll start with that. I happen to know what the having looked at the historical data that's available from here, what that day is. It wasn't too long ago. So for New England, the max demand happened on Friday, the 12th, and it happened at 4 o'clock or 1600 hours. So let's see if I can choose 1600 hours.
And it's quiet, but it's loading. So we have dead air at the moment.
Yes.
Yes.
There we go. There we go. All right. So if you want to look at the data for New England, one way you can do it is to roll over the circle for New England. And what you get is a pop-up box that gives you the data values, the 4 data values for New England for that hour. We also provide a percentage for differential between forecast and actual demand in the middle there. So to answer the question, we want to start with the interchange, and that's the number at the bottom, and it says negative 3,399. The negative indicates that the power is flowing into the New England system. If it was positive, it would be flowing out of the New England system. So that's how much is coming in from the outside. And we also want to look at what the actual demand is, and that's at the top. So that's 25,463. And if you divide the interchange by the demand, you'll get a percentage of the demand that's being satisfied by external sources, which if you do the math is about 13%. So that's the answer for that particular hour, the question that we raised. So you may want, so that's one way to do it, but you may want to look at the information a little more detailed and perhaps more than just an hour. So you can do that easily by clicking, instead of mousing over, you can click on the New England circle, balancing authority circle, and here we come up with this actually brings up the third page on the tool. So we moved on to that. And what we're showing here is, in the top chart here, is hourly actual and forecast demand for 2 days based upon the day that we were looking at before, which is August 12th. And so, you know, you can pick information off of here, and we show some other things. We show here a differential between forecast and actual demand. And then this chart here in the middle with all the blue lines dropping down is the interchange or the inflow and outflow of electricity from the New England system. So you can see it's fairly consistent importing for these particular days, and you know, we can pick off the particular hour that there's our there's our 4 o'clock hour there, the 3,399 right there. So one of the things that folks might want to be interested to see is, all right, so they're importing a lot of energy. Well, where are they getting it from? And so we can look at that. And let me just jump quickly back to the status map. And let's see if I can do this right. We can actually zoom in. Let's see if I can grab this. And so just to look more closely at New England, and we can see who New England is interconnected with. So it's interconnected with 3 balancing authorities, the New York ISO, Hydro-Quebec, which is up here, and New Brunswick. So those are the 3 entities that we would expect to want to see how much power is coming in from each of those. So we can click back on this, go to the detailed data page, and scroll down to the bottom. And what we see in the middle of the page here, some colored lines. These represent the imports of electricity from those 3 systems. Just to point this out, up toward this line here, up toward the top is the 0 line. So most of what we're seeing here is negative numbers, which is consistent with what we were seeing above. The yellow line at the bottom is Hydro-Quebec, and so this is around 2,000 megawatts, pretty consistent over those 2 days. It's not surprising because Hydro-Quebec and New England have a long-term contract to bring in significant amounts of power from their hydro system. And then the green line is New Brunswick, with somewhat less imports, but fairly steady, not as steady as Hydro-Quebec. And then the brown line is New York, which is also, during these days, this importing for the most part, except for the early morning hours on the first day. So that's a way of looking at where power is coming from. The other thing that particularly analysts may be interested in is, well, how do I get the data? So, this is all nice and good, and we can look at things and we can analyze some things, but hey, I just want to get the data and run with it and do some things. So every chart here up in the upper right-hand corner has a download button to it. We can open that up, and there are two formats for getting the image of the chart. There's a data download. If you want to get the data that is being presented on the chart, you can download that data. And then there's a way of copying the chart itself that you can then paste into a web page. And this will allow you to present this chart on your own web page, and the data will be updated automatically. All right, so another way to get data is to go up here in the upper left-hand corner under the scroll bar, and instead of looking at the graph, we can look at the data table. So this brings up the 4 data elements for New England for this period, and scroll over to our 4 p.m. hour, and here are the top is the demand value that we were using for our calculation, and the bottom is the interchange value. But now we've added forecast demand and the net generation value there. So for this data table, it also has a download function in the upper right-hand corner. This looks a little different from the one I showed you before. there's a way of getting to EIA's open data page related to the API data series that make this data available. And it'll take you to some information about how to use the Excel add-in. There's also a way of doing a bulk download of API data, and that will take you there. If you want to download some database files instead, you can use this drop-down menu to select a file, and these files are sort of taking 6 months chunks of data from the database that you can download. So you select that and hit the download button. All right, so another way to get the data series is, I'm almost finished, thank you. Another way to get the data series is to use the API key on this page, and so we'll just click on that. And what it brings up is, here's the open data page. Here is so this is our API query browser, which you can use to find all the data series that are available from EIA. Top here is the API call, which is important for being able to grab the data. Gives you a chart of the data series, and you can see this data series starts on July 1st, 2015, and goes to today. And then below that is a table with the data in it. All right, so there was one other thing I wanted to mention on the map before we move to questions. So let's start with the overview. I mentioned selecting regions, and so here are the regions that we have available. I'm guessing for most of you, these regions are unfamiliar to you. You're probably used to NERC regions. So, you know, what the heck's this all about? Why did we do this? So if you go to the map, these regions, we believe, better represent how the industry, how the operations in the industry are organized. And so each of these regions are roll-ups of data from the balancing authority level. And so they follow the contours of the footprints of the balancing authorities. And that's probably a major difference that you'll see. Now, I know that there are a lot of folks from state folks on the call. I know that you like to get your data in, state-by-state basis, at a state level. Unfortunately, the nature of this information does not allow for us to present it on a state-by-state basis. The only state that is represented here is New York State, and that's because their electric system, their footprint basically follows the contours of the state. Now, the value of looking at this for state people is to better understand how the electric systems that are in your state that supply electricity in your state fit into the whole picture of how the U.S. grid is set up. And we've got a bunch of different configurations. So we've got New England. Of course, there's one system that serves 6 states, but you can go down and look at Florida, and there are 11 systems that supply, power in that state. So So there's lots of differences in terms of how these electric systems match up or don't match up with the states. So, all right, so why don't we stop there and move on to questions.
Well, thank you for that presentation, Bill. We have quite a few questions, and I want to thank everyone for submitting them during Bill's presentation. Let's get started with a question on the example that you were navigating, Bill, as it relates to ISO New England.
Yeah.
The question is, so if I'm getting it right, at 1600, which I believe is the hour that you were looking at,
yeah.
ISO New England was exporting and importing at the same time.
No. So the nature of interchange, how it's measured, is that so power may be flowing in and out of the system, and if you've got multiple systems connected to it, yes, in a particular hour, power may be flowing in from one and flowing out to another. That can happen. In this particular case, for that particular hour, power was flowing in from all three of the neighboring systems into New England. So I'm not sure why you're thinking that it's flowing in and out. I mean, now it is. So this is just representing at the system level what's going on. Now these lines here between New England and these other systems actually represent multiple lines, and it's perfectly possible that during that hour, power would be flowing, one way on one line, in on one line and out on another line. That type of thing will happen. And even on a single line during that hour, it may be, flowing in at a certain point and later in the hour flowing out. So the number that we are collecting, which is net interchange, the net means that we're just looking at over the hour, what was the average? And so that average can only be in one direction or the other.
Switching gears, the next question is, can we find available generation capacity within authorities?
So not directly in this tool. However, EIA does collect information on its 860 form, and which lists the plants and units within plants, data about units within plants in the U.S. And on that form, we list what balancing authority they are associated with. And so using that data, you can answer that question.
Similar question to the one we just answered. Is there a way to isolate data for a single company within an operating system?
So no. So the one thing that's very important to understand is that this data is only at the system level. And when I mean system, I mean the balancing authority level. It does not give you any more granularity in terms of what's making up that system, whether it's generators or whether it's utilities within that balancing authority.
Are there any plans to show a breakout of where the energy source comes from in the tool? For example, coal, natural gas, hydro, or renewables? So
we're currently in the comment period for proposed revisions, a new clearance cycle for the 930. And one of the proposals that we're making is to ask or require balancing authorities to report to us their net generation broken down by a set of standard fuel types. So the answer is yes.
Are there any plans to include wholesale energy prices in the tool?
So No. So we have been, working on, separately from this, we have been working on developing access to RTO energy prices, and this is a work in progress at the moment, and not associated. So this tool has no prices in it, and I don't know what once we're able to develop our RTO portal, as we're talking about it at the moment, we'll have to think about what the relationships we'd have. One thing we can say is that all 7 RTOs are represented in this tool at the moment, because they all happen to be a balancing authority, in addition to being an energy market and many other things.
One question that relates to generation within a particular state: will the model or data be detailed enough to see the effects of renewable generation in California, for example, what has been called the duck curve?
So currently, the information we have is not adequate for us to use this information to create a version of the duck curve. And the reason for that is that the duck curve depends upon information specific to the output of renewable resources. And so we don't have that yet. But as I mentioned earlier, for an earlier question, we do plan to add that capability. And once we have that, we would be able to, or anybody would be able to use the information to create duck curves.
Are there plans to create a toggle to view the load data from a NERC region and geographical region perspective?
No. So we don't have that information, for those regions. So I'm assuming you're when you're saying geographic regions, you're saying something different from the regions that we're presenting here today. And so we're just not collecting the data that way.
Why is the daily demand curve megawatt hours instead of megawatts? So one can get into a philosophical discussion about whether it's megawatts or megawatt hours. The reality is that for an hour, the two units are identical to each other. So yes, we've had suggestions that we should change this or that or the other thing, but I think most people understand what we're talking about. When you say data for noon in Eastern Standard Time, is that summation of data for noon in Eastern Standard Time, 11 a.m. in Central Standard Time, 10 a.m. in Mountain Time, and so on and so forth?
That for the U.S. aggregate, you're absolutely right. That is, we are when we're aggregating for the same time period. In those different time zones, they happen to be, named a different hour.
Is the data for prior year, prior week, and prior day real-time data, day-ahead data, or historical data?
So I think, other than the demand forecasts, everything that we're talking about here is historical data. So it's not day-ahead. So the demand forecasts are a day-ahead forecast, but everything else is historical.
How are transmission losses accounted for in the reported data?
So that's really, the best answer I can give you is that we don't know. That is based upon how each of the balancing authorities choose to represent their system data. I believe that in most cases, system losses are included in demand.
What was net generation netted by? Is that indicative of station use? Also, is pump storage loading treated as demand or as a reduction to generation?
So again, both of those have to do with how the reporting entity handles those. So I can't tell you definitively what the answer is. Net generation is net of station use, yes.
I need one moment here, please bear with me. Is there a way to get data for any residential home in any area?
So, okay, so this is a great question. So one of the things I'm trying to convey to folks is that this is looking at the U.S. electric system from a very high level perspective, that is at the system level. So there is no information here about household level anything. This is the total electric system. The generators in the particular area, the load-serving entities in the particular area, the end users in that particular area, and the transmission and distribution facilities in that area. All that wrapped up into, just a few numbers each hour.
And just to follow up on that, Bill, so the tool's not going to show people something happening in a residential neighborhood, an outage, something small, or a squirrel did something at a wire. But is it able to see something in a bigger area if there's an outage for, I don't know, any major event? And has there been an example of that you've seen?
Right. So of course, that depends on a couple of things. So how big the outage is, but it's really how big the outage is relative to how big the size of the region is. So we've had a lot of customer outages in Louisiana recently because of flooding. Fortunately, Louisiana, so if we click this chart, or we just mouse over this chart, we can see the region that Louisiana is part of, and it's the largest geographic region in the country. So even though the number of customers that lost power was very large, it's still very small compared to all the customers in this particular region. So my guess is that we wouldn't be able to see the effect there. However, we did have an incident earlier this summer or spring in Tacoma. So Tacoma is very different from this system we're talking about that Louisiana is in, which is MISO. So Tacoma is up in the Pacific Northwest, and let me find it here. There's Tacoma. And so they're, a city. So it's fairly small relative to some of these other balancing authorities out here. And they had an incident where they lost power in their central business district around noontime. And that was significant enough that we were able to look at the demand data that they were reporting to us and see a noticeable dip in demand for that hour. So yes, depending on the circumstances, you may or may not be able to see the incidence of power outages.
I think we have time for just two more questions. If the demand data is day ahead, why are you waiting until 20 minutes after the hour?
So let's be clear about what we're collecting about demand. We're collecting two things about the demand. The first thing is we are collecting a day-ahead demand forecast. And what that means is that the electric system is doing a forecast. so, electric system did a forecast yesterday afternoon of what demand would be today. So that's a day-ahead forecast. And they report that to us in the morning of today. Separate from that, we are receiving every hour the actual demand that took place. And so that is not a day-ahead value. That is a value for the most recent hour. So that's the distinction there.
And our final question of the webinar, are there plans to include an hourly phasor angle snapshot per balancing authority for a more clear stability visualization of the grid?
So the quick answer to that is no. And I'd have to actually think about that a little to be able to figure out if that would relate to what we're doing here at all. And before we go, I wanted to mention one other thing here. At the bottom of, for those who are interested in using the data, and I did mention that this is still a beta, and so we have significant data quality issues that we're working to resolve. On both the map page and the detailed data page, down at the bottom on the left-hand side is a link to a PDF document called Data Users Guide and Known Issues. And so this is a document that will help you understand what the data is, how to get access to the data, and talk about some of the, there's some peculiarities about these balancing authorities that you probably should be aware of that we list here. We have a discussion here about the nature of some of the data quality issues that we're dealing with in general. And then we have a listing down here of specific issues for the balancing authorities of so if you're planning to use this data to do something, you probably want to look at this document before you do that.
And along those lines, if someone goes to use the tool a few days from now and you might forget some of the intricate functionalities that Bill mentioned, you can visit EIA's YouTube page where we have a series of tutorial videos that helps you navigate the different functionalities of the electric system operating data tool.
Okay.
So with that, I wanted to thank everyone for joining us today. We appreciate the time that you took out of your busy schedules to take part in this event. Please feel free to try out the tool on your own using the knowledge that you gained today. If you have any questions or feedback, please feel free to submit those questions via EIA's beta page or by emailing Bill at william.booth@eia.gov, which is on the screen in front of you.
Right. So it's part of the presentation that was sent to you.
Thanks, everyone. We hope you enjoy the rest of your day.